This video is about Avogadro's law, which is a very simple but important thing that helps people figure out how many atoms are in a compound and so forth. So even before they knew there was atoms, Avogadro postulated that the volume of a gas is related to the amount of a gas. Now, of course, amount could be two different things. One is the number of molecules. The other is the weight. And it turns out it's the number of molecules. So if you take water, which is H2O, okay, you can break down water with electricity to form hydrogen gas and oxygen gas at the two electrodes. Now, when you do that, it turns out that the volume of the hydrogen gas is twice as big as the volume of the oxygen gas, because in water there's twice as many hydrogen atoms and they both produce a diatomic molecule in the gas. They also knew that oxygen is much heavier than hydrogen, but the question would be, is it 16 times heavier, which is what we actually know now, or is it 8 times heavier? Well, if you didn't know it was a 2-to-1 ratio, you'd think it was 8 times heavier, but now we know, since it's a 2-to-1 ratio, it's got to be 16 times heavier. All right, so we're just going to work a real simple problem or two. First problem. What is volume of 4 grams of methane? All right, now, actually I want to change this question a little bit, because the volume depends on things like temperature and pressure. But if you specify a standard temperature and pressure, which is abbreviated STP, the standard temperature is not room temperature, but it's 0 Celsius, 273 K, and the standard pressure is 1 atmosphere. So we could use the ideal gas law, PV equals nRT, to solve this, where we convert grams to moles and we'd have N. So we can actually go ahead and calculate that. There's 16 grams of methane in 1 mole of methane. And the number of moles of gas is 0.25. All right, so we could do all this, but it turns out we can use a shortcut, and that is the fact that all gases at STP, if you have 1 mole of gas at STP, and that's equal to 22.414 liters. Okay, and so basically the volume of 1/4 of a mole of any gas is going to be 1/4 of 22.414, and so let's just figure out what that is. And that's 5.6 liters. All right, so you could get that either way. Using PV equals nRT, you should get V equals 5.6 liters, or using this as conversion factor, where it's 22.414 liters in 1 mole, and then multiply that by 0.250 mole. And you get 5.6 liters. Okay, and so a second problem would be just working it in reverse. So first thing to do is convert the liters to moles. We're just going to say 8.00 liters at STP. Multiply by 22.414. Liters at STP is 1 mole of helium. And we'll go ahead and just convert the moles of helium to grams of helium. 1 mole of helium is 4.0 grams of helium. And just calculate all our numbers and we are done. Okay, so 8 divided by 22.414 times 4, 1.5 0.43 grams.